Labdien! Ir noslēdzies Latvijas Sēklaudzētāju Asociācijas rīkotais Pirmais Sēklu Kongress, kurā uzmanība tika vērsta uz selekciju un tās nozīmi jaunu šķirņu radīšanā. Tika runāts par vietējo Latvijas un ārzemju selekciju, par augu šķirņu aizsardzības likumdošanu Latvijā un Eiropas Savienībā, kā arī raisījās diskusijas par nozarē aktuālākajiem jautājumiem. Ar savu prezentāciju uzstājās arī SAATEN-UNION pārstāvis no Vācijas, selekcionārs doktors László Cselényi, kurš skaidroja, ka jaunu šķirņu radīšana ir ilgtermiņa un augsti profesionāls process, kurā apvienojas zinātne, inovācijas un praktiskā lauksaimniecība. Sertificēta šķirnes sēkla nav tikai produkts, tas ir ieguldījums nākotnes lauksaimniecībā. Un lauksaimnieka iegādātā sertificētā sēkla un samaksātā autora atlīdzība ir selekcionāru resursi jaunu, mums piemērotu šķirņu radīšanā. Piedāvājums nelielu ieskatu doktora László Cselényi prezentācijā.
Good afternoon and congratulations to your first SEED Congress. It's a great honor for me to be part of it. And thank you for the invitation. My name is László Cselényi. I am Hungarian and I have been working for more than 2 decades for WFOMBODES Eckendorf. This is our headquarter in Hovedissen in North Rhine-Westphalia in Germany. We are developing winter barley and winter wheat varieties, and these varieties are internationally distributed by the SAATEN-UNION and in some countries by RAPUL. In the Baltic states we are represented by RAPUL Baltic, and my colleagues by RAPUL Baltic asked me to talk about plant breeding, seed, certified seed production and farm-safe seed. But before I am diving into the topic, just a short comment. I am so happy to see so many women in the audience. If we were in Germany, I think it would be a men's talk. And another comment, I think women should take over the power, not just in Latvia in the seed production, but in the politics in the entire world. We would have a better world. So, and yet let's talk about plant breeding. This slide showcases the entire process. Our aim is to provide the farmers with high quality certified seed, and the process starts with the development on new varieties. These varieties are submitted to the national authorities. In Germany it is the Bundessortenamt, and these authorities take care that varieties meet all requirements to get registered in the country. On the one hand, the varieties need to be distinct to other varieties, uniform and stable, and on the other hand, there is a performance yield performance test. It takes typically 3 years, where the varieties have to be superior to already registered plant varieties. And if the varieties meet all requirements, the authority can list the varieties, so the varieties get registered, and a seed can be placed on the market. Usually certified seed, but we will see it's not always the case. You could ask me why we need new varieties. We have already high-performing varieties, but if you consider the agricultural production is very complicated biological system with huge impacts from inside and from outside the system. It's not just the climate change, but changing social and political circumstances can force the farmers to use less chemical agents or apply less fertilizers, and we have to protect some areas and not to mention the expansion of the organic farming is important aspect as well. So that brings us to our breeding goals. We have to improve the tolerance and increase the resistance to plant diseases, and we have to strengthen the resilience of our varieties to abiotic stresses like heat or cold or drought. And not less important is to keep the yield performance of the varieties under altered circumstances. Plant breeding is not new. It started around 12,000 years ago with the domestication of several important crops. You can see some crops on this timeline. And it was just a simple selection, and Gregor Mendel, a monk, revolutionized this process in 1866 with his experience. The results of this experience were lying about 30 years in drawers until they were rediscovered in 1900, and that was the start of the modern plant breeding, and this is still the basis of our work. We use the combination technique to create new variability, and you may know there are two different types of crops. Some crops are self-pollinating and some are cross-pollinating, and in cross-pollinating crops you can produce hybrid seed, and we take advantage from natural mutations. And since the 1990s, we use biotechnology more and more. We have already heard this morning about tissue culture and double haploid technique, and we get more and more information about the genomes of our crops, so we can use molecular markers. We started using genetic engineering in the early 2000s, and marker-assisted selection is a very important tool in our breeding programs. And it goes towards genome editing. Genome editing not just use observations and measurements, but the molecular data combined with these statistical methods. So it's the modernist technique we have at the moment. The variety development can always split into 3 steps. The first step is always the creation of new variability. We have different methods to reach this, with combination breeding, interspecific crosses, protoplast fusions, genetic engineering, and with the new breeding techniques with CRISPR-Cas and with genome editing as well. And we have a huge diversity. We have to select for our desired combinations. And in the plant breeding, there are some very important techniques established. The conventional pedigree and bulk and SSD techniques, and the double haploid technique in the biotechnology, And we have already heard about speed breeding in the greenhouse. You can grow several generations in 1 year and accelerate your breeding process. And once you have your new varieties, you have to maintain them, and you have to produce seed of these new varieties. This slide contains a lot of information. The main question is on the left side, if you want to create a green round pea and you have a yellow round and a green wrinklet pea, is it possible or not? The answer is yes, but it's not that simple. And it's basically what Gregor Mendel experienced 170 years ago. And in the middle you can see the whole process. He combined yellow round and green wrinkled peas, and in the first generation he observed only yellow and round peas, and it's a phenomenon which is called the dominance of alleles. If you each individuum has 2 alleles, one from the mother and one from the father. And in the first generation, if you cross 2 homozygous individuums, you always have heterozygous situation, and one dominant allele can mask the recessive allele, and that's why you cannot see any green and wrinkled peas in F1. And if you go further in the second generation, there's a segregation, and it's really a big chaos. And it's a blessing on the one hand, because without this segregation we would be not able to develop new varieties. But it's a disadvantage as well, because it's not that easy to find your desired traits in this mix. And that was the reason why the plant breeder tried to find new methods, and that is the double haploid breeding. In that case, there is only one recombination after the hybridization, and we take the sperm cells out of the flower and cultivate them on an artificial medium, and this medium brings the cells to become plants. And because there is no further segregation, by doubling the chromosome set, you can get in only 2 years genetically fixed lines. And this is a more effective basis for your selection. Here's the whole process. The DH technology is really the most innovative method in winter crops breeding, not just in winter barley, but in winter wheat as well. You can grow the crossing parents in the summer, and in August you get the results and plan your crosses. In October you can combine your parents, and 3 weeks later you can take the embryos and put them on an artificial medium and cultivate them and grow them in the greenhouse later. The microspore, the ears are cut in a very special stage, where the sperm cells can take another way to become a plant, but not a pollen. And you can see on the bottom line the microspore culture with developing new in vitro plants. And in August, the new regenerated plants can be adopted in the growing chamber and we plant them in September. So all the steps in only 1 year. It's very innovative and very fast. Plant breeding is a very time and effort-consuming process. It takes at least 6-7 years, and here you can see a comparison of 3 different methods. The pedigree breeding is the conventional breeding method. If you don't have any facilities, no biotech lab, no greenhouse, you have to grow every generation on the field, and it takes at least 8 years to develop a new variety. With speed breeding, you can accelerate your process in the greenhouse, and as I said, in the DH production, the fixation of the lines is only in one step in 1 year, and you can start with the selection in the 2nd year and develop your lines. In orange, there you can see the official trials. It's typically 3 years long in Germany in cereals. And the 2 columns on the right side, we start with the breeding on one location with the crossing of several hundred crossing parents. We create a very huge variability, and year for year we reduce the number of the varieties, and we go with our varieties to other sites, so we get results nationwide and sometimes from other countries as well. The breeding objectives are in general very yield focused. The most important trait is the yield potential, and there are some characteristics which can, that's why it's very important to score for plant length, heading date, ripeness, winter hardiness. We have to examine the susceptibility of the varieties to plant pathogens, and we have to score the straw stability as well. And of course, the yield quality is very important. If you use wheat for food, baking quality is important, and if you grow barley for beer production, then it's malting quality very important. Once you have your varieties, you can not sell them. There is an official testing carried out by national authorities. You submit your varieties, and in this testing system, all varieties are tested compared with well-known varieties. And after 3 years, if the varieties perform well and are superior to all registered varieties, the varieties can be registered. And it's main prerequisite for selling seed later. But that's only a half success. After registration, we have in Germany a federal system. We have in each state post-registration trials, and after registration you can send your varieties into these trials, and the performance of the varieties in these trials is very important as well. We start the seed production 5 years before registration. On the top of the slide you can see our field design from last year. We have on the blue area, we have about 300 lines in NL-2, that means 2 years before submission, and 1 year later in NL-1 we prepare about 80 varieties for submission. It's a lot of work. We know that we are not going to submit all varieties, but we have to produce seed for all varieties because we don't know at this time which varieties will be submitted. We separate, that is barley, we separate the varieties based on color, in one block the red and in one block the green varieties to avoid cross-pollination. Then, and you can see on the picture the varieties are isolated by rye. Rye grows faster and gets taller, so at pollination the rye can prevent cross-pollination here. So it's a lot of work. We go through this field several times a year, and we remove everything what doesn't belong to the variety. We don't produce certified seed on our own. We don't have the capacity, we don't have the field. We are the plant variety right owner, and we prepare the seed for production of the certified seed, but it is done by seed production companies and by this network under contract. And this is very important to know. The certified seed is our property, but not produced at our place. So provided this is 1,000 kilogram big bag wheat, and it's a German variety and produced by Wax in Latvia. The price consists of several components. You have to pay for the standard crop price, for packaging, transport, for storage, for overheads, for seed treatment, for certification fee and producer's fee, and there's a profit margin as well. And if there's 1,000 kilogram bag costs 800 euros, it's a realistic wheat price in Germany. I don't know the prices in Latvia, but only a very small part goes to the breeders. So we had the discussion this morning about national security and what remains in Latvia and what goes abroad. In case it's a German variety, it's a very small part what leaves the country. The main part stays in Latvia, and a lot of German companies and farmers take advantage of this variety. And maybe another comment, royalty is the only one revenue of the plant breeder, so without royalty is no breeding possible. It's always worth buying certified seed. Why? You get an exact 1,000 green weight for your precise sowing rate. There is a verified germination rate. There are no off types and very high technical purity and variety purity, and the seed is healthy. And if something goes wrong, you can complain, and the seed is, of course, professionally treated. In the certified seed is a genetically improved variety with enhanced traits. There is a better nutrient efficiency, there is an improved processing quality or optimized water management. Of course, it's there is homogeneous ripeness and homogeneous emergency provided with the seed. The variety purity is provided as well, and the highest yield, and the seed is adapted to the climate change. So on this slide you can see the growing areas for several important crops in Germany: winter wheat, winter barley, rye, triticale, spring barley, and so on. And if you multiply these growing areas with the seed amount per hectare, you get the seed demand for the crop. And of course you have your sales numbers, and the difference is farm saved seed. And you can see in Germany we have about 50% seed exchange rate in winter wheat, 66% in winter barley, and in average in winter cereals 57% seed exchange and 43% farm saved seed usage. In general, you can say you are allowed to use farm saved seed in Germany under two conditions. One condition is that you pay royalties, and another condition is that you respond to a declaration request. There is an exception as well. If your farm is not bigger than 20 hectares, or in case of potato, not bigger than 5 hectares, you don't need to pay royalties, but you have to respond the declaration request. The plant breeders, there is a federal association of German plant breeders in Germany. That's a very big association with 130 members, and all members assigned this association to establish an office, the Seed Trust Administration Office, with dealing of all royalty affairs. This office has two departments. One department deals with certified seed royalties, and then other department with farm saved seed royalties. We have already heard about different systems in Europe, how the royalty can be collected. In Germany, this office sends a form sheet to roughly 80 or 90,000 farmers in April, on which the farmers can declare the use of farm saved seed. And when the office has any information which indicate that the farmer could have used farm saved seed, this is already on this form. And the royalties are calculated on the amounts of declared and invoiced to the farmers. Yes, and if the farmer does not comply with their obligations, then they have to pay damages In one case it says the full license, but in repeated cases it can be 4 times the full license fee. And they have to declare that they don't do it again. And in some cases, if it's a violation of the law, the case can end up at court. So the farm safe seed royalty collection system is very simple in Germany. The Breeders Association established this office, and this office is the only one contact point to the breeders and to the farmers. The farmer receives only one request to file the farm safety declaration and only a single invoice, regardless how many varieties the farmer has used. And this office gathers all payments and share the royalties to the breeders according to the declarations. You can see it would be almost not manageable without this office, because we have 130 breeders and 90,000 farmers and more than 3,500 varieties. So it's a big challenge. And the office publishes every year a newsletter, and in this newsletter you can see a list of all important and relevant varieties. There is the name of the variety, the plant variety owner, and you can see the certified seed license fee and the farm safe seed license fee as well, and it's the half of the certified seed license. And I think I'm at the end, and I hope I was able to highlight some important aspects of plant breeding and seed production in Germany, and thank you for your attention.
What I'm talking about that for those who don't understand this detailed, it's a really interesting presentation. It's so much details and so much work from the beginning to the variety. And there's some couple of very practical questions.
Okay.
Also, average income from wheat in Europe per hectare in Germany. Farmer grow wheat, for example. You know.
Average yield.
Average income.
Average income
from wheat grower from farm.
It's between 1,000 and 2,000 euros, I think. But I can not say exactly. I'm a plant breeder and I'm not very familiar with this business. But we have very different geographical regions. In Bavaria, the average yield 80 decitons and 8 tons. And in the north, you can harvest more than 10 tons. So the market is divided into quality production in the east and feed wheat production in the west.
8 tons, kas interesējas par ražām Vācijā, tad ir ienākuma attiecīgi, cik citajā gadā maksā tonu speciālists ražošanā. And subsidies, Germany and Hungary, is its difference, and do you know the difference between these two topics?
Sorry, I didn't catch it.
Hungary as a country, I mean, and Germany, is a difference with subsidies.
So with the subsidies.
Yeah, subsidies. That's a top question from us always. Subsidies, do we have enough? Do you know what plus minus the average of, for example, the winter wheat, very popular, subsidies per hectare?
I cannot say.
Okay,
I'm sorry.
That's fine. Of course, you're breeder, not the seed production company. Vēl kāds jautājums? Ne par cenām, lūdzu, ne par kilogramiem tur un tam līdzīgi. Par sēklaudzēšanu, vairāk par šo tēmu.
Viņam noteikti ir zināms, apmēram, cik izmaksā viena šķirnes selekcija Vācijā.
Sure, the price, plus minus, of course, the average, the price, total price, that's the question for one variety, specific variety, if somebody asks to make it. It's plus minus 10 years, 7, 8, 10 years work. How does it cost?
Millions.
Probably doesn't know. The 3 tips, yeah. Right? The 3 tips, that's it. Yeah.
Just the official testing. If you submit 10 varieties, one variety costs 6,000 euros. But if you submit 10 varieties to official testing, 70,000 euros, just the official testing. And one plot costs 30 euros, and we have 30,000 plots countrywide, so it's very expensive, yeah, really.
70 tūkstoši lauki maksā lauciņi mazie, un tā ir ļoti daudz iziet certifikāciju, tas ir jādara katru gadu, tie atkārtojumi un gadi. Nu, tad tie 70, 30, 40, 50 tūkstoši krājās, un kā jūs redzējāt šeit. Nu, lai būtu izpratni par to, ko tas nozīmē, jo vispār mums jau liekas, ka var mierīgi to uztaisīt šitā, un tad attiecīgi arī par šito nemaksāt. Nu, tas ir tas mums parastais piegājiens gadīgi bijis. Bet, lai izpratnē par to, ko tas vispār nozīmē. Jo šādi turpināt kā mums, tad nav jāgadīt, ka tad vācieši dara to tālāk, un tad mēs to vispār nedaram, ka mums varam importēt. Ja mums viss patīk, kā ir šobrīd. Tas mums visiem attiecīgi, lai sarunātu savā starpā, un mēs saprast, kas ko dara, un kādu darbu, kādu nežēlību ārkārtīgi darbību šķirnes selekcionāri. Jā, tas ir vēl kāds jautājums ir par šo nevienkāršo tēmu. Tāpat nav zinām, tas ir selekcija. Vispār selekcionāru var kļūt, kurš arī kurš nav tāda likuma, kā kļūt par selekcionāru, un jūs varat kļūt par to. Tas vien papraši izpildu visu. Ja nav jautājumi, tad izskaidrībā, ja mēs esam ļoti tuvu diskusiju. Thank you very much.
Yep, thank you.
Turpināsim.